Do you want to build chatbot like ChatGPT using your own data? If so, Langchain is the go-to framework for this purpose. By now, many people have already come across Langchain, and it's a well-known framework in the AI community. I myself have shared 8 different videos on Langchain that includes retrieval augmented generation RAG, advanced RAG, Langchain streaming to get faster response, and deploying your Langchain apps on Streamlit, and so on. This video will cover the crash course on how you can use different components in Langchain that includes large language model, prompt templates, output parser, vector database, embeddings, memory, and so on. So let's dive in. Before we can proceed, let's start with the installation. In order to get started, we need to install Langchain and Langchain Community, which are the library to use the components that we need. And then we have PyPDF. When you build retrieval augmented generation pipeline, you need a document loader to get your external data. In our example, we will use PDF as our external data. Then we have ChromaDB, that is our vector database to store the embeddings of your data. Then we have fast embeddings. So you might ask me the question, why are we using fast embeddings to convert our text into embedding instead of OpenAI? When it comes to OpenAI, there are already many videos out there that is using OpenAI as the large language model and the embedding model. But it is not accessible to all. Why? Because you have to pay for it. This is where in our complete crash course, we will be using open source large language models from HuggingFace. When it comes to HuggingFace, you can use LLMs, you can use embedding model. Embedding model, if you want to load model very quickly, this is where we have fast embeddings that is being developed by Qdrun team. So let's get started. Once you do the installation part, we will start with our first component, that is the large language model. So large language model is where you add the intelligence to get the better response from the AI model. So you can imagine that you have the data. If you want to get better responses to the user query from the data, you need a large language model associated with it. So whenever you're using Langchain, there are 3 things you need to keep in mind when you are choosing the large language model. The first thing is model name. So the model name can be GPT-3, it can be GPT-4, it can be Gemini, it can be Gemma, you have Mixtral, Llama, and there are so many other open source models which we have out there. And not just open source, there are also closed source such as GPT, Gemini, then we have Claude as well from Anthropic. So these are the model names. You can experiment with different model names and you can pick any one of them. In our video, we will mainly focus on open source model that is fine-tuned on Mistral, and the model name is Zephyr. The reason why I use Zephyr the most is because of the hallucination index. It is very close to GPT-based models. And once you pick your model name, the second thing is you need to decide what should be the model keyword arguments. Model, I'll just write model quarks, which is keyword arguments. And few of the model keyword arguments is temperature. Then you have something called as maximum tokens. Maximum tokens is very important because when you give your input, there should also be the number of limit that the LLM needs to return. Why? Because each model has certain context length until which it can hold the data. If you are giving very large maximum tokens, and if it is generating that many tokens, it's a kind of disadvantage or limitation on your end. That's where you need to give the maximum tokens. And then you have something called as top P as well. And if you are using open source model, then you also need to pay close attention on full return full text. So this should be false so that you don't add your wait, let me check. It should be false. Yeah, it should be false. So what return full text does is whenever AI generates the response, there are high chances your prompt is also included in the response. That's where if you give return full text to be false, it won't generate. And the last thing that you need to keep in mind is the prompt template. So each LLM model has its own template that you're supposed to use. When it comes to closed source model, you don't have to much worry about it. But when it comes to open source model, you're supposed to use the template that the model needs. So these are the three things that you need to keep in mind. So let's proceed, and we will start off with how you can use HuggingFace Hub. So from Langchain Community dot LLMs, I'll use HuggingFace Hub. HuggingFace Hub. And now what I need to do is I need to set up my API key. So what I'll do is I will set up HuggingFace access token. And in order to get your access token, the first step is you need to go to huggingface.co. You need to create your account. Once you create your account, you need to click on settings, and then you need to go to access tokens. You can create a new key. And once you create a new key, it should be in the right role. And once you have that key with you, you can just come out to the screen and you can paste it. So what I'll do is I'll let me copy my key. I've already copied my key now. So now what I'll do is I will store my key inside the environment variable. So in order to store my key inside environment variable, I'll use something called as import OS, and from getPass import getPass, then os dot environment. Now you need to pay very close attention. I need to use HuggingFace Hub underscore API token. It should be same as it is. You can't make anything change. It should be in capital letter. HuggingFace Hub API token equals to get pass, and you can enter anything. In our case, I'll just tell enter your key. Enter your API key. I'll run this. Let me copy my key again so that I'll double check it. And I pasted it. Cool. So now what we have done is we have imported HuggingFace Hub, and we have also set up our access token, which is our HuggingFace access token. Now I will define LLM, that is HuggingFace Hub. And the first thing is you have repo ID. The repo ID, in our case, I'll be using HuggingFace H4. Then you have Zephyr model, Zephyr 7 billion beta. So let me show that model to you. I'll just copy this. So this is the model name. So whenever you open HuggingFace, right, you will have the repository ID name, and then you will have the model name. You're supposed to copy this. So whenever you copy, it will copy both the repo ID and the model name. So this is what we are supposed to paste it here. The first thing is the repository name, and the second thing is the model name. And then we define the model keyword arguments, model keyword arguments. And here, the first thing will be the maximum token. We have max new tokens. I'll keep it to be 1024. And then we have temperature. Temperature, if you need randomness, then it can be more than 0.5. If you don't need randomness, it can be less than 0.5. So in our case, I'll just use 0.1. That's it. So we have defined two parameters, and there are a few more parameters. As you can see here, I told you we need temperature, max tokens, top P, return full text. I'll ignore top P for now. Instead of that, I'll use something called as repetition penalty. So what repetition penalty does is, whenever there is any repetition in the response, and if you want to limit it, the value of repetition penalty should be more than 1. So in our case, I'll keep it to be 1.1. And then you can have return full text to be false. So these are the few things. We'll also come to the prompt template next, but for time being, we'll only focus on how you can inference a large language model using Langchain. So in order to inference it, you just have to run something called as LLM.invoke. And you can add any query that you need. In our case, I'll just tell what is the meaning of life. So this is my prompt. I just want LLM to return what is the meaning in life, and I'll just print the response. And there are two ways you can do this. One is you can run LLM.invoke that will wait for some time and it will generate the response. If you need streaming, so what streaming does is if you want to generate the response word by word, then you can use something called a stream. And we will talk about stream when we will use Langchain expression language. So this LCEL stands for Langchain expression language. We will come to that part and I'll explain you what streaming is and what is batching. So for time being, we have already got the response, the question that has plagued philosophers, and we have the response, what is the meaning of life. So this is how you can use large language models. There are different models that you can use. I'll give you the suggestion on what models you can use instead of HuggingFace. My personal favorite, it is Grok. So Grok has low inference latency. So what low inference latency is nothing but you will get a very quicker response from the large language model, and it uses API and it has a large language model which is open source. My second favorite will be Gemini. You can directly get it from Google Studio, Google AI Studio. The reason why I like Gemini is because of the context length. It has around 2 million context length for their Flash model. And my third favorite will be Claude, which is their 3.5 Sonnet. It's probably a very advanced LLM, I'll say. The quality of Claude is phenomenal. And then I'll have OpenAI. Here I'll take GPT-4. And then you'll have something called as HuggingFace. Cool. In our video, we are using HuggingFace. Cool. Let's proceed. Let's use prompt template now. And in order to pick prompt template, in our case, we will be using chat prompt template. And you can use from Langchain core.prompts import chat prompt template. So now let's define the prompt template. For each model, you have its own prompt template that you're supposed to use. If not, I'll tell you what will happen. So what we will do in prompt template is we will define different template. In first template, we will directly give user to enter his response. In the second template, we will tell user to give the proper structure of it. So let's see how it works. And just like large language model, where you were supposed to focus on 3 things, in prompt template, you need to focus on 2 things. The first thing is the system prompt. And then you have the user prompt. So what's the difference between system prompt and user prompt? System prompt means that you're giving certain instruction to the large language model to follow. For example, let's suppose you want to build a medical chatbot. When you're building a medical chatbot, you want a large language model to behave like a doctor. It needs to behave like an expert professor or any other thing. If you want that kind of feature for large language model to adapt, this is where you need to give those instruction, those role inside system prompt. For example, you are an expert researcher, or you are an expert competitive programmer who can solve any given Python questions, Python or C++ question. And there are also chances like whenever you build an application, you want large language model to restrict something. So let's say you're building a math agent, like math assistant, and you don't want that particular max assistant to answer any other question apart from max. So let's try that thing. Let's try that particular system prompt in our example. So now what is user prompt? User prompt, it's nothing but whether you need to give step-by-step guide to the LLM, or it can be the normal prompt as well. It can be normal prompt as well. Normal user query. So let's define this. Let's define the template. We will define multiple templates in our video. So this is the first template, chat prompt template dot from messages. And then what I'll do is I'll define the system prompt. The first thing is I'll define the system prompt, and the system prompt is you are an math assistant. You only answer max questions and nothing else. So there are two things here you need to focus. The first thing is when you define the system prompt, you are giving certain instruction. And the second thing is you're also giving what it needs to restrict. The limitation of the large language model is that you don't need to answer anything that comes out of math question. So this is the restriction that you're providing. And then you have the user prompt. So for the user prompt, again, you have to create the parenthesis, and then you will define user. User, I'll just give something called as input variable. So this is something that you need to understand now. What is input variable? Let me give the syntax. Input. So whenever you want the input coming from the user, in Langchain, we enclose that inside curly brackets. So in our case, this particular input, so whatever you see here, right? This particular curly bracket, inside this, what you have input is the input variable. Just to avoid confusion, instead of input, I'll just keep it as query. So this query is nothing but the input variable. So this is how you need to define the input variable, where you don't know exactly what to give. You're waiting for the user to enter that value. Again, you can check out the syntax. You need to use chat prompt template dot from messages. You open the parenthesis. Inside the square bracket, you need to define two different tuple. The first tuple will contain the system prompt, and the second tuple will contain the user query. So let's run this. And now you will define the prompt. Prompt equals to template dot format messages. Here you can override your input variable. So what I'll do is I'll write query equals to what is the meaning of life. So what should be the response? The response should be that large language model should not generate any response. It should tell, hey, you're out of context. I can't answer to your question. So let's run this. I'll run this particular prompt. And in order to inference the large language model, we need to use something called as LLM.invoke. You just have to run prompt. That's it. So it should tell that it should not give me the response. Rather, it should tell I don't know. Let's check the response. Assistant, as you see, I'm sorry, but as a math assistant, I'm not programmed to answer philosophical question. My primary function is to assist you with math related queries. If you have math question, please don't hesitate to ask. It didn't give me the response to what is the meaning of life. I'm using the same LLM. Make sure I'm using the same LLM before as well. Before it has generated the response. Now it has not generated the response. Why? Because I'm restricting it within the system prompt. So this is one way to define the prompt template. Now, if you notice one thing, right? One thing is when you generate the response, you have this additional keyword called assistant. I'll ask one more query. So what I'll do is I'll ask one more prompt, template dot format messages. Here my query is solve 9x plus 10 equals to 80, return question and answer in JSON. Okay, so this is my prompt. And now if I print this, print LLM dot invoke the prompt to. So it is starting the response with the keyword called assistant. And I don't want the large language model to start the response with the assistant. And here it is still worst. It is starting with something called as format, and then it is written something called as assistant. So this is what you call as garbage. So if you notice what I've written here, there are three things you need to keep in mind when you are inferencing the large language model. The first thing is what model name you are picking. The second thing is the keyword arguments. The third thing is prompt template. Prompt template should be specific. So in our case, we will use HuggingFace. Since we are using this FR model, you need to check for the prompt template. So if you look at this comment, right, you have system prompt, then you are closing it with yes. Let me copy this. Let me copy this comment. So now if I copy this comment, as you can see, first we have system. After system, you are defining the prompt. Then you are closing your system prompt using has keyword. Then again, you are opening your user prompt. Then you are closing it. And then you have assistant. So we are supposed to follow this format. So let's write the prompt now. I'll define the template to. Template to, it's nothing but chat from template dot from template. So the first thing is I need to copy the system. Let me delete this. I'll paste it here. So once you have the system, I'll define the same prompt. Let me remove this. You are an math assistant. You only answer math question and nothing else. I'll copy this. I will paste it here. Then I will close it. And in order to close, you just have to use \s. And then you need to use something called as user prompt. User. And you'll just take query. Again, you have to close it. And then you have assistant. For assistant, I'm not generating anything. I want large language model to just generate the response. That's it. So this is the second template. I'll run this and I'll copy the same prompt. Just notice I'll copy the same prompt. I'll create a new cell. So I'm copying this prompt to, I'm copying this, create a new cell, paste it. So instead of prompt 2, I'll make it prompt 3. Instead of template, I'll make it template 2. And the message remains the same. I want the LLM to solve 9x plus 10 equals to 80. And it needs to generate the response in question and answer, which is in JSON format. So let me run this. Now if I print the response, okay, I need to use LLM. LLM dot invoke prompt 3. There is no assistant keyword. It has given me the JSON format. So let me save this inside a variable. Response 3 equals to LLM dot invoke prompt 3. So when I print the response 3, it is in the complete JSON format and there is no extra keyword. So let me check with the previous response. When I run the prompt 2, as you can see, you have format and assistant. Why? Because your template, your first template, it is this template. You have system, you have user. So this template is basically used for closed source model such as Claude, Gemini, and GPT. It won't work for open source model. This is where for each model, you have its own prompt template. You need to define the prompt template and then you need to format the user query. Here you need to notice is if I give here something else, suppose if I give here question. So now what will happen? whenever you want to use an input variable, it should be enclosed inside curly brackets. So here my input variable now is question. If I run this, and now if I run this, it should be an error. Why? Because there is no key called query. The key is question. So you have to be very sure whatever input variable you use, you just have to override that particular input variable. If it is not matching, then you have key error. So this is something everyone needs to notice. And now you're generating the response and you're getting the actual JSON format. But here there is an issue. If I print this, suppose if I print the type of it, print type of the response 3, it is in string. So technically, whenever I have a JSON format, it should not be in string, rather it should be in a dictionary. So this is where we come to the third concept for today, that is the output parsers. Output parser. So what output parser will do is, whatever response you're getting in string, you will convert that into the actual JSON format so that you can parse it properly. So in order to use that, first we need to define the schema. So just like before, let's see what you need to keep in mind. One is you need to define the response schema. So response schema will take the name of your JSON. So what is the name? You have question and answer. The key, that is the name, which is the key. And then you need to give specific description. It should be point to what you need. It's like this description will be added as a prompt to your large language model. So you need to be very specific to what description that particular key holds. So this is what you can think as value. And then you just have to get the format instructions from the output parser. So the format instructions is nothing but whether you need to convert your response in the markdown fashion of the JSON. That's the format instruction, which is the part of prompt that you need to give. And the third thing is, once you get the response, once we get the response, you need to parse it. So when it comes to open source model, there are sometimes we get error. Why? Because it doesn't parse properly. This is where closed source model performs very well for output parser. But let's still check out from Langchain dot output parsers, import response schema and structured output parser. So these are the two things that you need to define. Now we need two keys. The first key is answer. The second key is, the first key is question. The second key is answer. So let's define the response schema. Response schema name equals to question. Then description equals to the answer to the question. Then we again define the response schema. Here the name of the key is answer. Sorry, I just miswrote this. It should be the question asked by the user. So this description will be the answer to the question. So these are the two response schema. Now what I'll do is I will define the actual response schema, which is the list of question, comma, answer. So this is the actual response schema that you need to pass inside your structured output parser. So now you need to define output parser. Output parser equals to structured. I'll just wait for autocomplete. Here you have something called as response schemas as your input variable, and it is something in list. So you need to pass the list of it. And what's the list? It's the response schema. I'll just copy this and I'll paste it here. So it's already in the type list. Okay, it says takes one positional argument, but two were given. Okay, my bad. So it will be like structured output parser dot from response schema. It should be dot from response schemas, and then you need to pass it. My bad. Cool. So now we have the output parser. So as you can see, once you define your response schema, the next thing is you need to get your format instructions. So I'll use format instruct as my input variable, and output parser dot get format instruction is the command. And once you run this, you have format instruct. This is nothing but a simple list, simple string. And in this string, you have the instruction saying that whatever response the large language model generates, it should be in this format. So as you can see, this is the format. The output should be in markdown code snippet formatted in the following schema, including the leading and trailing. So it's like you're giving the markdown syntax so that it is easy to parse. And now what you need to do is you need to add this particular instruct inside your prompt template. So what you need to do is copy the same template, copy the same template. And here what you need to do is you need to add instruct. So where do you add instruct? You need to add instruct in the system prompt. Pay close attention. You're copying the same template. I'll make this as template 3. Once you copy this template, you are giving the system prompt. In system prompt, you have already defined what that LLM is and what it needs to limit. And then you are giving the instruction that whatever output you generate, it should be a markdown code for JSON. And then you use user query. In user query, we just take the user question. That's it. So now how many input variables do we have? We have 2 input variables. We have 2 input variables. One is you have instruct, and one more you have question. So let's take a quiz now. What you need to do is you need to add the next line of how you need to format the message. Just pause the video, think for 2 minutes on how you will override the 2 input variables. And once you have done that, play the video, and then you can proceed with this particular video session. So I hope you have paused the video. Cool. I'll wait for a few seconds. Let's see if you have completed it or not, and then we will proceed. All right. I just hope you have already completed. I've defined my prompt 4. In prompt 4, what I'll do is I'll define template 3. And then I need to use the function called format messages. Format messages. Here, I need to define instruct. Instruct, it's nothing but the format instruct variable that I have. It's a string. And then you have one more input variable. Input variable is nothing but the question. One is you have instruct, one more is you have question. Here you need to define the user query. That's it. This is it. And now you just have to run it. And in order to run, I'll define a new variable called response. Response 4 equals to LLM dot invoke prompt 4. And then you just print response 4. This is pretty quick. Like each of the response that we are getting, it's only taking 4 seconds, 2 seconds, which is quite good. So now you have the JSON format. As you can see, you have the response inside the leading trail, which is the JSON markdown snippet, and it is stopping at this particular trailing edge. So what you need to do now is the third step. Now we have the response. Once you have the response, you need to parse it. And in order to parse, I'll just write parser equals to output parser. It's the same output parser that you have defined here. Output parser equals to structured output parser dot from response schema, where you have added the list of that. And initially we use something called as get format instructions. Now what we will do is we will use parser equals to output parser dot parse and response 4. Hopefully it should not give me an error. It worked. So now if I print it, parser, it should be a dictionary. This is the dictionary what I need. Now if I print the type of it, type of parser, it is dictionary. So it's the same thing. When you run prompt template, give it to the large language model, it will give you string. But when you take the prompt template, use it for the response schema, define what you need, and then if you parse it, when you parse, before that you need to give format instruction, then parse, get the response. This time you will have your response in the dictionary, that is nothing but your JSON format itself. Now, whatever you want, you can do. Like I'll just write parser dot, I'll just tell get question, and I'll get the response. If the same thing I repeat in the previous LLM response, it will give me an error. Why? Because string doesn't support get function. So you get the attribute error. So we have completed the 3 parts. Now comes the very exciting part. And to the advanced user who is learning Langchain, he needs to know something called as Langchain expression language. This is very, very, very important because whatever RAG application you will build, you will do it using Langchain expression language. So this is the very interesting part of this video, Langchain expression language. And we will cover 3 things. One is the simple syntax to inference LLM with prompt with output parser. And then we will use something called as Langchain streaming. So what streaming will do is return the response word by word. Return the response word by word. Then you have batching. So what batching does? Give 2 queries at a time, 2 or more queries at a time. So these are the different syntax that you can use from Langchain expression language. And moreover to this, you can also perform something called as async operations. In our video, we will not cover this because in Colab, keeping it async or normal doesn't matter that much. But if you're using Streamlit application, then probably you need to check out the async operations as well. The syntax is same. Suppose if I use invoke, right? I'm using invoke prompt. The syntax for async will be a invoke, and then you'll have prompt. So it's something similar only. You can check out the documentation. Cool. So let's proceed with the simple syntax. So what Langchain expression language does is it does the piping mechanism. It's that you can combine your prompt, large language model, and output parser in a single line using pipe symbol in your keyboard. So let's try that out. I'll just write a chain. I want to connect the chain, but before that, let's copy certain prompt. I'll copy this prompt. This will be the prompt. Let me check with the syntax. Chat prompt template dot from template. This is correct. What you need to do is just copy what you have done before. And one thing is remove instruct. We don't need instruct now. Okay, so we just have a prompt where you're directly giving your chat prompt template from template. One thing is we are not using format message here. You only define prompt. That's it. And next, for output parser, I'll use something called as from Langchain dot. It should be from Langchain.core output parsers import str output parser. Okay, so here what we will do is we don't need our response to be in JSON. We want our response to be in proper string. So this is what we are trying to do. And the shortcut command is we just combine them in a single line using Langchain expression language. And it is very simple. Just write prompt, add the pipe symbol, LLM, add the pipe symbol, add the str output parser. That's it. This is the simple syntax of Langchain expression language, and it is so simple. You don't have to think much about it. And now what you need to do is just run chain dot invoke whatever input variable you have. What is the input variable? You have question. If you have multiple input variable, you need to create a dictionary. You need to create a dictionary for multiple question. Suppose I have question as my first input variable, then I have something called as instruct. So if you have multiple input variables, create a dictionary. And now I'll just give input variable as question, and I'll define what is life. So it should not give me the response. Why? Because it's a math assistant. It doesn't know anything apart from math. Cool. So as you can see, I'm not capable of having the personal opinion or belief, but for from a scientific perspective, okay, it did generate the response, which it shouldn't have done. But if you look at the starting point, it has told that it is not capable of it. And you can tweak this prompt a bit and you can get the better response. So this is the simple syntax of Langchain expression language, where we just use the pipe symbol. Cool. So now that we know how the invoke works, the next part is we will look into the streaming part. So let's go line by line. The simple syntax is done. We will use the same syntax to build retrieval augmented generation pipeline as well. But for time being, let's proceed with streaming. Streaming. And now I'll define the same response, and I'll use chain dot stream. So previously what we did, I'll just name it as response so that you won't confuse yourself. I'll just response invoke. Response invoke. And I'll also print the type just so you will know the difference between them. So the type of response invoke will be string. As you can see, it is string. Now what we are doing is, instead of running chain.invoke, we are running chain.stream. So the syntax is same. I'll copy the same thing what I've added inside invoke and I'll paste it here. Now if I print the type of response, it is a generator. It's not a string, rather it is a generator. Can you see it's a generator? And now if I print response, you just have the object ID. It's not generating the response. It is only the object, which is runnable sequence. You will come across what is runnable when we will build a retrieval augmented generation pipeline. But for time being, just understand, whenever you're using streaming, it is a generator and it returns the object. And if you want to execute this streaming, you need to run a for loop. For chunk in response, I want to print each chunk and I want to end everything in the one line. And then you have an additional parameter called flush, which needs to be true, so that you get the feeling of it's generating one word at a time. And as you can see, it is 0 second. But if you have a very long response in retrieval augmented generation, you will see the difference that it generates one word at a time. Now, since it is very fast, you're not able to see it. But if the response length, it is very big, whenever it takes 4 seconds, right, for invoke, that time you will see the difference. It is generating one word at a time. So this is what the chunk does. You can remove this to see the difference. I'll just run this. Okay, I need to run this again. Like, okay, this is again one more downside. Whenever you use streaming, right, you can only run that object for one single time. Next time when you run that again, you need to rerun everything. So if I rerun this now, it will be empty. As you can see, it is empty. This is where you need to rerun this again. Now, if you can see, you're generating the response. So this is where streaming is very important, where whenever you're building any application on Streamlit, that difference of not making the user wait and not giving the delay message, streaming will be very useful. So now let's come to the very interesting part. what if you have two different inputs, right? This is where we have batching in LCEL, which is Langchain expression language. Cool. So now let's proceed with the two different prompts. I'll just write batch response equals to chain dot batch. And now I have two different questions. So as you can see, I'm running chain dot batch. Whatever input variable I have inside prompt template, you need to define that. So this is my first prompt. Then inside this curly bracket, sorry, square brackets. So inside these square brackets, I have two different questions. So I have two different questions and it is inside the square brackets. And you just have to run this. And now I'll print the batch response 0. So this will be the response for what is live. I'll take a mathematical question. I'll tell solve x where equation equals to 7x plus 45 equals to 34 plus 2x. So now it will generate batch response 0, which is solving the mathematical question. And if I print batch response to be 1, it will tell me the response of what is meaning of life. As you can see, it's saying, I'm sorry, but an math assistant, I'm not programmed to answer philosophical questions, which is correct. Got it. So now let's proceed with the next part. Let me check what is the next part. We have completed what is LLM. We have completed prompt template. We have completed output parser. We have completed LCEL. Now let's start with vector database and embedding. So let me create the subheading of it. Now it's time for vector database and embeddings. Cool. So why do we need vector database and why do we need embedding? If you want to understand that, I have linked a particular video. You can check out this video in the I. So what this video does is it will tell you the process of how you can build retrieval augmented generation, where vector database and embedding plays a very vital role. I'll just give you a clue of what it does. You have the external data. The external data is a string or an object. Whenever you're building a deep learning based model, you can't understand or a model can't understand English. That's where you need to convert that into the vector representation so that you can create your LLM based application. So this is where embedding model comes into the picture. So what vector database does is it stores the embedding that is getting generated so that it can perform search technique. A normal database, it can just store the data in the table format. Vector database has the capabilities to run the search techniques such as cosine similarity, maximum marginal relevancy. This is the capability of vector database. So let's import them from Langchain Community dot embeddings import fast embeddings. So this is how you import it. And now what you need to do is you need to define the model name. There are only few supported models that Qrent has added for fast embeddings. We'll just use one among them. And the best of the LLM or the embedding model that fast embeddings provide is the NLPR GTE large. The NLPR GTE large. So this is the embedding model that we will be using. And you just have to click this particular cell. What it will do is it will load the model from HuggingFace. Once it loads the model, let's continue. It's gonna take just few seconds. Okay, so for some reason it is generating the issue like the validation error, but that's fine. What we will do is we will change the model into HuggingFace embeddings. So what I'll do is from Langchain Community dot embeddings import. We'll use something called as HuggingFace inference embeddings. I'll use HuggingFace inference API embeddings. I'll run this. And here I need to add my HF token. HF token, it's nothing but the same HuggingFace API. So enter your HuggingFace API token. So let me quickly copy my token. Sorry guys, I guess we'll not proceed with fast embeddings. The other will use HuggingFace embeddings. So I'll copy my embedding. I'll copy the access token. I'll paste it here. Cool. So now we'll define the embeddings. Embeddings equals to HuggingFace inference API embeddings. And inside this, you need to define the model name. The model name is same. I'll use the NLPer GTE large. And here I need to define the token, which is HF token. I just hope it, okay, I guess it's returning an error. Let me check the syntax. Let's check the syntax. Langchain, HuggingFace, inference, API, embeddings. Okay, so it should be API key and the model name. API key equals to HF token, and this should be model name. Hopefully this should not give me any error. Let's see. Cool, it works. And if in case you want to verify it, you can use something called as embeddings.embed. Let me check out the syntax as well. I actually forgot the syntax. Yeah, it is embedded query. So I'll copy this. I'll paste it here. So embeddings.embedded query, I'll just write what is life. So this will return a vector representation of this particular query result. And this will generate the embeddings of it. This is weird. It's taking some time to generate the response, but that should be fine. Cool. As you can see, it has generated the response. It has taken around 21 seconds to generate it. And I'll remove this response for time being. So what I'll do is I'll create few sentences. I'll create few documents. I'll create docs equals to 4 sentence. So the first sentence is, you can write any 4 prompt that you need. So let's quickly write 4 prompt. What is the meaning of life? This is my first prompt. And then I'll just write, what does Ikigai teaches us? So this is my second prompt. And then I'll ask, who is the author of Rich Dad and Poor Dad? I'll tell you the reason why we are writing these 4 queries, so that I'll convert this text into embeddings, and then I will store it in a vector database. That's the reason why we need some additional queries, so that it will be useful to store it. Can I learn AI after Python? So these are the 4 queries that I'll give. And now what I'll do is, instead of using embeddings.embed query, I'll use something called as embed documents. So embeddings.embed, it's documents, and I'll pass docs. So this will create the embeddings. Okay, this was pretty quick. It took around 21 seconds for single query, but for document, it has just taken 1 second. So maybe that was the initial loading time of the model. That might be the reason. So if I print what's the length of embed docs, it should be 4. It is 4. And the embed docs, the 0th index, if I check the shape of it, it should be around 1024, if I'm not wrong. Okay, let me check what is the type of it. Okay, it's a list. So I'll just use length. I guess it should be 1024. I might be wrong. Okay, it's 1024. I was correct. So this is the length of the embedding model that the GTE large embedding model is using. So now that we know how the embedding model is working, the next thing is we will use a vector database. And in our case, the vector database is Chroma. So from Langchain Community dot, so from Langchain Community dot vector stores import Chroma. Okay, did I make a mistake? Okay, this is wrong. The spelling of community is wrong. It should be single T. From Langchain Community dot vector stores import Chroma. Now comes the very interesting part. How do you store your embeddings into ChromaDB? That's where you have a command called from documents. So if you look at DB Chroma, pay very close attention. Why? Because this is very important. So whenever you use ChromaDB, you need to create the embedding of your data. So that's where you use from documents, and you need to give two things. One is your text data. Text data, it's nothing but whatever data you have. And then you need to give the embeddings function. The embeddings function. And the embeddings function is nothing but HuggingFace inference API. If I run this, it should give me an error. As you can see, it has generated an error. Why? I wanted to generate this error because I wanted to show something different. Whenever you use ChromaDB or use Langchain, you need to follow a schema, right? So when you store your data, right, it should have certain schema in which it stores the data. That's where whatever external document that you have, it needs to have two different schema. One is page content and one more is metadata. So let me give you an example. Suppose you have a PDF. When you extract the data from your PDF, it will have the content of your data, right, in PDF. That is your page content. The page number, page 1, page 2, page 3. This numbers is nothing but a metadata. So whenever a user asks a query saying that, hey, what is the author name of Ikigai? You are generating the response from the page content, and metadata can be useful to tell where that answer is generating from. So this is where whenever you use document loaders, right, from Langchain, it will automatically add the schema of page content and metadata. So in order to do this manually, we need to use the schema from Langchain dot schema import document. And then you need to define it. So now let's define the document. Document is the list or information in docs. So what is the docs? Docs is nothing but a normal string that we have. And what I'll do is I'll do document dot append. Here I'll use the schema. The schema is nothing but document, which is in capital D. Inside that, you need to define two things. One is the page content. What is the page content? What I'm looping, the information. And then you have something called as metadata. The metadata is a dictionary. You need to pass the dictionary. I'll just tell source. I'll write unknown. Or I'll just tell example. Source is an example. And instead of docs, here I need to pass document. So this should not give me an error. and it will take 1 or 2 seconds and it will create a VectorDB. So now if you see, when I run this, it has created a vector database object. Why is vector database important? We'll create a different video for it because it's a very lengthy process. In short, just imagine in vector database, we can perform search techniques such as MMR. I'll just write few of the search technique. We have MMR, which stands for maximum marginal relevancy. It is one of the search technique. Then you have similarity search. Then you have similarity search with threshold. Similarity search with threshold is one of the technique as well. So now let's define one of the search technique and let's see how it works. So what I'll do is I'll just write db dot maximum marginal relevancy. Yeah, so this is the search and I'll just write what is the meaning of life. Now what it will do is whatever database you have created, it will rank them. So as you can see, my first document, what it is returning, it is telling what is the meaning of life. Then you have what does Ikigai teaches us. So these are the documents that is getting generated. If you want to lower this, you can use k equals to 2. So as you can see, it is only generating 2 different documents. And your first document is related to what is meaning of life. Now, if I ask just Ikigai, let's say if I just ask Ikigai, it will do the search and it will return what does Ikigai teach us. Okay, it should have been teaches us, but yeah, it's fine. So this is the way of how you can do the search technique. And when it comes to retriever, right, we need to convert our vector database as a retriever. So in order to do that, we just have to write db dot as retriever. And inside this, you can define your search type to be MMR. So MMR is nothing but maximum marginal relevancy. And then you can define search k equals to 2. That's it. So now instead of running maximum relevancy search, you can just run retriever dot invoke. And you can pass the same query. What is Ikigai? So what it will do is it will return the document. The first document will have what does Ikigai teaches us. Okay, so it is generating total 4 documents, which needs to generate only 2. Got it. So let's try with this. Search keyword documents equals to K2. Let's try with this approach. Right. So instead of directly giving k equals to 2, we need to give it inside search keyword argument equals to k is 2. Now we are getting the relevant documents. So there are 2 ways. The first way is define your DB, then add the search technique and get the relevant documents. Second, define it as a retriever that can be used for RAG. And inside RAG, you can give what search type you need. It can be MMR, it can be similarity by default. And then in order to define the number of documents that you need to return, you can define K. Okay, so now let's proceed. We have already done a lot in vector database and embedding. Now let's proceed to the core part of a chatbot. That's the memory it can retain. And when it comes to LCEL, there is probably still in beta version where it's not that efficient of memory. That's where we will use chains from the first version. So now what we'll do is from Langchain.chains, I'll import LLM chain. So inside LLM chain, I can define the memory that is nothing but conversation buffer memory. In order to define conversation buffer memory, I'll do from Langchain.memory import conversation buffer memory, and from Langchain core, from Langchain core dot prompts, I need to import the prompt template. So these are the three things that I need to import now. One is the LLM chain. So what chain will do is, it is similar to Langchain expression language. You are combining your prompt, LLM and output parser. Chain will do the same thing. I'm not using Langchain expression language. Rather, I'm using the class that will combine prompt, language model, and memory. So let's quickly define the template. Template equals to, you are an AI assistant, and I need to define the chat history. Chat history is nothing but the keyword that you need to give for the memory. And then you can ask the human message. Human message is nothing but the question. And then chatbot. So this is the standard prompt template that you can use. The first thing is you can define what your prompt needs to be, the instruction. Then the chat history, where each and every conversation is stored. This is just the input variable for the conversation memory key that we need. And then you have human. Human is nothing but what's the human input, the input variable. So once you define the template, you need to add that inside prompt template. And I don't want to use dot from template. Rather, I'll directly give template. And I need to define the input variables as well. Input variables are two input variables. One is chat history and one more is question. Okay, I need to define template equals to template. Fine. Template equals to template. Cool. So now that we have prompt ready, the next thing is you need to define memory. In memory, we have already imported conversation buffer memory. Copy this, paste it here, and you need to add what is the memory key. Memory key is just chat history. Memory key equals to chat history. And if in case you want to define the question as well, which is your input key, that is fine. In our case, I don't want to define it as now. So I'll just run this cell. And now you need to combine them. You need to combine your prompt, memory, and large language model. And in order to combine this, we have the LLM chain. I'll run the chain. Chain equals to LLM chain. I need to add LLM, which is the HuggingFace LLM. Then prompt, the latest prompt that we have used. And then we have to use memory. Memory equals to memory. Okay, I made the spelling mistake. Memory equals to memory, and I'll keep verbose to be true. The reason why I'm keeping verbose true is so that I can show you what is happening in the backend. Now I'll just run response equals to chain dot predict. I'll tell something about myself. I'll tell about myself. Large language model technically will not know who I am. So since you are looking at the jacket, I'll just tell my name is Tarun Jain. I love anime, and currently I am wearing Zenitsu jacket. So this is the prompt that I've given. I've just written, my name is Tarun Jain. I love anime, and currently I'm wearing the Zenitsu jacket. Now what I'll do is I'll add a follow-up question. So here what I'll do now is I'll just ask, what jacket is Tarun wearing? So this is the query that I'm asking. So as you can see here, it's telling you are an AI assistant. And when you print the response, right? When you print the response, it will tell, I Tarun Jain, it's great to know that you are a fan of anime and are currently wearing Zenitsu jacket. Zenitsu Agastama is a character from the popular anime series Demon Slayer Kimetsu no Yaiba. And you have got the particular response from the LLM. But the thing is, now what I will do is I'll ask a follow-up question asking what jacket is Tarun wearing. So you're using the same chain. And if you look at the chain, my previous history has my name is Tarun Jain. I love anime and currently I'm wearing Zenitsu jacket. Now, if I ask the response or I print the response, it will have the memory of it. When I print this, Tarun is currently wearing a Zenitsu jacket. So this is how you can include memory using the chains. You have LLM chain, you have something called as conversational chain, and here you also have something called as conversation window. So what window buffer memory does is how many previous conversation do you need to store? That's where conversation window memory will come, and this is the task for you. And you can probably complete this task and you can open a PR on awesome RAG repository and I'll merge them. So this will be the task so that you can follow along with me. And the task is how you can use conversation buffer memory window for the LLM chain. Now let's see what is pending. Let's scroll back. We have completed the LLM. We have completed prompt template. We have completed output parser. We have completed LCEL, which is Langchain expression language. We have completed vector database and embedding. We have completed memory. And now comes the final part of this video. That is how you can build a Langchain retrieval augmented generation pipeline. And for this, I've already created 8 different videos, but still I'll explain in this video on how you can build one. So let's go. So this will be the final part. I'll just write final part of this video is RAG, retrieval augmented generation. So there are 3 steps. The first step is you do the retriever. The retriever, what it will do is based on the user query, return the documents. Return the relevant documents. This is where I'll do search. The search will be MMR. Okay. So this is what does in R. So RAG stands for retrieval augmented generation. Step 1 is R. Step 2 is A. In my step 2, I will define or augment the prompt template. So what prompt template does? Whenever you do RAG, right? What is RAG? RAG, it's nothing but you're chatting with your own data. It's like creating chatbot like ChatGPT using your own data, right? So this is where first you retrieve the relevant documents based on the user query, and then you augment the prompt. If the user query is not there in the context, you just tell, I don't know. So this kind of instruction needs to be given in the prompt template, which is the augmentation. And last part is step 3, which is your generator. Here you give the relevant documents as in context learning with prompt. This is the augmented prompt to large language model. It's like you're giving the context query as a prompt. This both is as a prompt to LLM. So this is the pipeline that we need to build. All right. So the first step is, in order to retrieve, you need to store the data into the vector database. And let's use document loaders, and I'll upload a PDF of mine. Resume. Downloads. I'll upload my resume, just a CV. It's a PDF file. So what you need to do is you need to define your data from Langchain Community document loaders. And what is the document that we have? It's a PDF. Import by PDF loader. And you can't directly get all the data and pass it to the large language model. Why? Because each large language model has a context length issue. That's where once you get your data, you need to create a chunk of it. So why is K important? For retriever, we are defining the K, right? The K, it's nothing but whatever data you have, you're creating a smaller chunk of it. The K will get the relevant documents out of the chunks which you have already defined. So in order to split, we will use from Langchain text splitter, import recursive character text splitter. And we have already defined embedding. We have already defined chroma. So I won't define them again. But there are 4 steps. You get their data, you chunk it, you create the embedding of it, and save in a vector database. Save in a vector database. So what is our embedding? It is the HuggingFace inference API. And what is the vector database? It's the chroma, which we have already imported. So let's define the data. Data equals to py PDF loader, and the path of my file. The path of the file is taruncv.pdf, and you just have to load. Notice one thing, when I print the data, you will see document, page content, and metadata. Document, page content, and metadata. This is the schema, right? When you use Langchain, automatically, when you load the data, it will create the schema. If you have your own custom text, that's where you have to use from Langchain.schema, import document. And I've already done that before. You can probably use the Colab notebook and check the syntax. So what I need to do now is I need to create the splitter. Text splitter, I'm adding recursive character text splitter, and I'm defining the chunk size. I'll define chunk size to be 1024, and my chunk overlap will be 0. So what is chunk size? When you have your external document, what should be the chunk size of each document? That's 1024 tokens. So when you have multiple documents, if you want to maintain one context of one chunk to the another chunk, that is where you use chunk overlap. Overlap, it's nothing but how many tokens are you supposed to use in the consecutive chunks. So I'll run this. And now you define the chunks, which is text splitter dot split documents. This is in document. If you notice the data that I have, it is in document. So you have to use text splitter dot split documents, and you need to pass the data. Understand this very clearly. When you load the data in Langchain, you're getting the document format. And when you need to split it, you need to split it where you have to define chunk size, chunk overlap, and you have to split it based on the documents. And you have the chunks now. Technically, since we have used 1000, it should have just one single chunk. It should be just one chunk because the data that I have is very small. No worries, it's more than 1000 tokens. It's fine. We have 3 different tokens now. So I'll reduce it so that you will see the difference. 512, I'll keep it 512. Now it should be 6 or 7. Okay, it is 5. That is fine. So now what we will do is we will define the embeddings, which is already defined earlier. So I'll just comment this out. And you need to define the DB chroma dot from documents. So what is the first thing? It is the list of the document. The list of the document is chunks. And then you have embeddings. So this will create the vector database. And if you're keen to understand how you can reuse the indexed data, this process is what you call as indexing. So what is indexing? When you get your data, you're storing that into the vector database and you're saving them. This is only one-step process. And here you can define something called as persist directory. Here I will not define persist directory because it will be over the scope of this video. But we already have one video that is how you can use Langchain with Qdrunt, where I've defined how you can use persist directory. You can check out that video in the description. So I've already defined DB. Now we define retriever. Retriever equals to DB dot as retriever. And I'm defining the same step, search type to be MMR and search keyword argument K to be 2. And I need to define the prompt template now. I'll define the prompt template. Key template equals to. So this is the prompt template for RAG. I'll define the system prompt. You are an AI assistant that follows instructions pretty well. Please be truthful and give direct answer. Please tell, or I'll tell you must tell. I don't know if the user query is not in the context. So context, it's nothing but what you're getting it from the large language model. So here what you'll do is you'll define context. Context, you are getting it from your vector database context. So close your system prompt and then you open the user prompt, user, and here you just have to pass the user query. Again, we close the user prompt and then you have to add the assistant. That's it. That's the augmented prompt template. And I'll define prompt equals to chat prompt template dot from template. And you have to define the template. So this is the prompt. Now what we are supposed to do is we will use Langchain expression language. We will combine LLM prompt. In prompt, you need to combine two things. One is your context and one more is your user query. So this is where we'll use something called as runnable pass-through. Why? Because we have the context from the code, but the user query is coming from the user side. That's where in order to get those data, we use something called as runnable pass-through. So it's part of the Langchain expression language. So from Langchain core, you have to use runnables, import runnable pass-through. Cool. So what you need to do is create the chain. And in order to create the chain, the first component is prompt. So in order to get the prompt, there are two things that you need to pass to the prompt. Those two things are the context. So define the context. Define the context. What is the context? It's the retriever. And the second thing is query. Query, it's not from the program side. That's where you directly use runnable pass-through. And then whatever context and query you have, give it to the prompt. And you have to use pipe. Instead of comma, you have to use pipe. And after you have the prompt, you give it to the LLM. And then we need to have the output parser, which is str output parser. I'll again repeat. Since we have a prompt, in that prompt, we are giving two different input variables. One is context and one more is query. This context, you're programmatically getting that from retriever. That's where you're directly defined it. And query, it's not programmatically being written. That's where you need to fetch it from runnable pass-through that a user will provide. And once you get this data, that's when you're passing it to the prompt. And you start it with pipe so that you have the pipeline of Langchain expression language. Then you define LLM, and then we have the output, which should be in string. And now what you need to do is just get the response. Chain.invoke. I'll ask about who is Tarun Jain. And I will run this. And now I need to just print the response. It took just 3 seconds. Tarun Jain is a person who has attended the Fest, Build with AI, and other events related to technology. He runs a YouTube channel named AI with Tarun with over 1,000 subscribers. This is correct. I actually added this information in my CV, and I'm getting those response directly from what I provided as my data source. You can play around with this and build a chat with your own data so that it's gonna be very fun-based project. One more thing is you can check out Qdrunt and Langchain video that I shared, where you will have the understanding of how to use persist directory. If not, I'll just give you a clue on how it needs to be done. So whenever you're creating this particular vector store, right, it should be one step process or one time process. The next time when I upload the same document, I need to use it from persist directory. That's where I'll open this directory. So if you see here, right, I only have sample data and a PDF. If I use something called as persist directory, I need to give a variable. The variable can be anything. I'll give db. And then you just have to use db.persist. Now, if I run this, right, you will observe it will create a folder called db. This db will create a SQLite file which has all the information of the embeddings that you have created. And this should happen once. When you do this, right, when you create the persist directory, you're passing the document. So now what you need to do is the next time when you run it, you directly have to use db equals to chroma, not from documents. Directly you have to define persist directory, which is db and embedding model. You just have to run this. That's it. It's as simple as it is. It's just 2 lines of code, and you can run all the step again. So now where are you getting the DB from? You are getting the DB from the saved data, not from the new document that you're feeding. Cool. Yeah. This is it from the video. We will have more videos coming on your way where we will build agentic workflow where LLM can behave like a human. And we have few more exciting videos coming soon. Do subscribe to the channel and stay updated. Thank you so much.